all, let's continue with the sign magnitude division. In this lecture, we'll see an example of sign magnitude division operation. I'm taking an example where my divisor B is 10001 and my dividend is 0111 followed by zeros. So I will take this as an example and I'll implement the flowchart and we'll check whether we got the same quotient and remainder as a result. So we have already discussed about this flowchart. So the left side of your flowchart contains checking for a divide overflow condition. If there is no overflow, then we'll continue with dividing the magnitude parts of your data. If there is a divide overflow and if this DVF flip-flop is set to 1, then we'll stop the process and we'll not continue with dividing the magnitude parts. If there is no overflow only, then we proceed with the dividing the magnitudes. So first we have to check whether there is an overflow situation in the division operation. So first we'll start with the left side of your flowchart where we check for an overflow condition in your division operation. My divisor is stored in B, which is 10001, and the dividend is stored in two registers A and Q. So the dividend is 01110000000. So the first 5 most significant bits are stored in A register and the remaining 5 bits are stored in Q register. So totally the dividend is stored in A and Q registers. So we'll first check if there is a divide overflow situation. So we'll check with the left side of the flowchart first. First we have to calculate QS implies AS and XOR BS to find your sign of your quotient. That is equals to, what is the sign of your divisor? AS is the sign of the dividend, which is a positive. XOR the sign of your divisor. So it gives me 0. So the sign of your quotient is 0, which is a positive sign. Then you have to initialize the sequence counter to n minus 1. So here, along with the sign bit, the divisor, so BS stores the sign bit of your divisor, which is 0, and AS QS stores the sign bit of your dividend. So all are positive. So sequence counter initialize to n minus 1, where n minus 1 represents the number of bits of your divisor without a sign bit. So without a sign bit, how many bits of your divisor? 5 bits. So it is initialized to a value 5. Okay. Next, we will perform EA implies A plus B complement plus 1. So to perform this, we have to first calculate B complement plus 1. So what is the value of B? 10001. Perform a B complement. It will give you 01110. Add it to 1. It will give you 01111. So this is nothing but B complement plus 1. So you have to add this value to A. So A value is 01110 plus B complement plus 1 is 01111. Add both of them 1, 1 plus 1, 1 0, 1 plus 1, 1 0 plus 1, 1 1, 1 plus 1, 1 0 plus 1, 1 1 and 1. So this will be stored in EA, where E stores your carry bit. Since there is no carry here, E is 1 and EA stores the value of 11101. So based on our flowchart, if E value is 0, it means that if E is equals to 0, it means A is less than B. In that case, we have to set your DVF flip-flop to 0, which means there is no divide overflow situation. And we should also perform EA implies A plus B to get back the original value of A. So what is the value of A now? A value is 11101. The new value of A now is 11101. To this you have to add B. What is the value of B? 10001. So you will get a value of 1 plus 1, 10, 1, 1, 1, 0, 1. So this is nothing but your carry which is stored in E flip-flop, and this is your value of A. So since DVF is equals to 0, there is no overflow. We continue with the next part of your flow chart. And DVF is set to 0. We'll start with dividing the magnitudes. So all this is check for overflow condition. Check for a overflow. Right? We will divide the magnitudes. Have to write E, A, Q and sequence counter. So what is the value of E? If you look here, the value of E is 1, the updated value, and A is 0110. Value of E is 1, 01110, and Q is 00000, and sequence counter is initialized to 5. Now we perform according to the flow chart. You have to perform shift left on the contents of E, A and Q. So when you perform a shift left, what happens? 0 will come here, 0 will be inserted in this position. So everything will be shifted 00000, and this 0 will come here, become 00111, and this 0 will come in place of E. Right? Now we check the value of E. So E is equals to 0. So when E equal to 0, what you have to do? You have to perform A plus B complement plus 1. So this is the value of A, and what is the value of B complement plus 1? B complement plus 1 is nothing but 01111. So we add this 01111. It gives you 1110, 11, and E becomes 1. So you get a carry out of this addition which is stored in a E flip-flop. So next you have to, after performing A plus B complement plus 1. So here what you are doing? EA implies, sequence counter is 5. EA implies A plus B complement plus 1. Now after this becomes 00000 and 5. Next you have to check the value of E again. Now E is equal to 1. So when E is equal to 1, what you have to do? You have to insert one bit in place of Qn. So it becomes 1010111, and Qn is nothing but this particular bit. So you have to insert 1, 00001, and sequence counter has to be decremented 4. So here what in this step what you are doing? Since E is equals to 1, you are inserting 1, and the sequence counter will be decremented by 1, right? So this is completed. The value of E is 1, A is 01011, 00001 and 4. Now we will repeat the process because the sequence counter is not equal to 0. So we have to perform again shift left on the contents of E, A and Q. So when you perform a shift left, here 0 will be inserted in place of Qnth bit, and 01000. and this 0 will come here, 0 1 1 0 1, and E becomes 0. So now we check the value of E. E is 0. So we perform A plus B complement plus 1. What is B complement? 0 1 1 1 1. Add it with A. 1 1 plus 1 1 0 1 1 1 0 1 0. So carry, you get a carry of 1 that will be stored in E flip flop, and 0 0 0 1 0. You are performing E is equal to 1. So you are performing A implies EA implies A plus B complement plus 1. Right? Now after performing, what you have to do? You have to again check the value of E. E is equals to 1. When E is equal to 1, what you have to do? You have to, so E is equal to 1. E is equal to 1. So you have to make qnth bit to 1, and sequence counter has to be decremented by 1. So qnth bit becomes 0 0 0 1 1, and your sequence counter becomes 3, and your values remains the same. Okay, this is one step. We'll continue. So now again start the flow chart. Perform a shift left on the contents of EAQ. So when you perform a shift left, it becomes, this becomes 0 0 1 1 0, and A becomes 0 1 0 1 0, and this becomes 0. So now E is equal to 0. You add it with B complement plus 1. So B complement plus 1 is 0 1 1 1 1. So you add it 0 1 1 1 1. So it becomes 1 1 0 1 0 1 1, and it becomes 1, and this is 0. Okay, and this is 0 0 1 1 0 and 3. So next step, now E is equals to 0. So when E is equal to 0, you have to perform EA implies A plus B, right? So what is the value of A? 11001. This is your value of A. You add B to it. So B is, what is B? 10001, not B complement plus 1. This is just B. Add them, you get a value of 1010, and your E bit will be 1. Okay. Zero zero 110 and 3. Now your E bit, check the E bit. So E bit is 1 0 1 0 1 0 0 0 1 1 0 3. Now you have to decrement your sequence counter. So sequence counter becomes 2. SC implies SC minus 1. Okay. Next step. So the content of E is 1 0 1 0 0 1 0 1 0 0 0 1 1 0, and sequence counter is 2. Now perform shift left on EAQ. So it becomes 0, 1 0 1 0 0, 0 1 1 0 0 and 2. Now check the value of E. E is 0. So E is 0. So you have to perform EA implies A plus B complement plus 1. So A is this. So to this add B complement plus 1, which is 0 1 1 1 1. So it becomes 0 0 0 1 1. Okay, and you will get a carry of 1. Okay, and 0 1 1 0 0 2. So now you have to check the value of E. So E is equals to 1. When E is equal to 1, you have to make the qnth bit to 1 and sequence counter has to be decremented by 1. So it becomes 1 0 0 0 1 1 0 1 1 0. Qnth bit, this is qnth bit. So it becomes 1 and sequence counter becomes 1. So this is one cycle. We'll continue. E is 1, A is 0 0 0 1 1, 0 1 1 0 1 and sequence counter is 1. So perform again shift left on the contents of EAQ. So it becomes 0 0 0 1 1 0, 1 1 0 1 0 and 1. Now check the value of E. So E is 0. When E is 0, you have to perform EA implies A plus B complement plus 1. Right? So this is my value of A. B complement plus 1 is 0 1 1 1 1. So add that, it becomes 1 1 plus 1 1 0, 1 plus 1 1 0 plus 1 1 1, 1 plus 1 1 0 1 and here you get a 0, no carry. So it becomes 1 1 0 1 0 1. Now you have to check the value of E. E is 0. When E is 0, you have to add A plus B. So E is 0 now. So we have to add EA implies A plus B. So this is the value of A. I am going to add B. B value is 1 0 0 0 1. This is the value of B. So when I add it, it becomes 0 1 1 0 1 0. I'll get a carry 1 here, so 0. And this becomes 1 1 0 1 0. So after adding A plus B, you should also decrement your sequence counter by 1. So it becomes 0. So whenever your sequence counter reaches 0, you have to stop the process. So since sequence counter is equal to 0, we need to end the process. So quotient is stored in Q. So what is in Q? 1 1 0 1 0 and remainder is stored in A. So what is the value of A? A value is 0 0 1 1 0. So which is nothing but 6 and this is 26. So your quotient is 6 and the remainder is 26. If you can check here 0 0 1 1 0, the remainder and the quotient is 1 1 0 1 0. The same thing we got here. So this is how we have to perform a sign magnitude division operation using the flowchart. Thank you.